Welcome back, everyone. In this section, we're going to focus on just a quick crash course in data visualization. So throughout this course, we're going to be visualizing a lot of our data, and we're going to be performing exploratory data analysis. So what this section is designed to do is really just briefly cover some of the data visualization techniques using two main libraries, and that is the Matplotlib library and the Seaborn library. Later on in the course, we'll also be exploring Panda's built-in plotting capabilities. Now keep in mind, this section is not a comprehensive overview of either of these libraries. Instead, we're simply going to go over some common syntax calls that you will see throughout the course. That way, when you see them when we're learning about deep learning or machine learning, they don't seem completely new and you're not focused on learning that syntax. Instead, you already know it having gone through this section. Thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to have a quick crash course on the Matplotlib plotting library for Python. Matplotlib is often referred to as the standard Python visualization library for data science and machine learning. Keep in mind that both Seaborn and Panda's built-in plotting functionality are built using Matplotlib library. So that means if later on you decide that you really just want to focus on using something like Seaborn for visualization because it has a simpler syntax, you'll still be able to make Matplotlib calls that directly connect with Seaborn because a lot of these other visualization libraries are built using Matplotlib. So we're going to be using Matplotlib throughout the course for just very basic plot types. Think of things like just plotting a simple line to see how our training performed. All right, let's head over to Jupyter Notebook and just go over a few of the basic topics for Matplotlib. Okay, here we are at a notebook where I've already imported NumPy as MP and Pandas as PD. Next, what I'm going to do is show you how to import Matplotlib for plotting purposes, which is import Matplotlib, and then you have to say dot pyplot, and then import it as PLT. So keep in mind, sometimes people forget this .pyplot. Go ahead and add that in. Next, what I'm going to show you is just how to simply plot an X array versus a Y array. So for example, let's say I had these 3 points on the X-axis, 0, 1, and 2, and on the Y-axis, essentially I wanted to plot 100, 200, and 300. And what I want to do is just do a very simple line plot of each X and Y pair. What I can do is say plt.plot and then say X, Y. And this is essentially the most basic line plot possible. We just have our X points, 0, 1, and 2, and then we have the 100, 200, 300. And by default, Matplotlib will go ahead and just do a line plot. Now, if you're running this in Jupyter Notebook and for some reason you only saw maybe a single output, but you didn't actually see the image, for older versions of Jupyter Notebook, what you need to do is add in this magic command just somewhere at the top of your notebook and then run it. What you need to do is say matplotlib space inline. And you do this with a %sign. So this is if you are using a notebook and for some reason you don't see the image. The latest version of Jupyter Notebook should show the images, but just in case it didn't, you can go ahead and run what's known as a magic command in Jupyter, which starts with this %sign, which is just matplotlib inline. And then if you rerun plt.plot, you should be able to see this. Now, if you're running this as a .py script, what you need to do is right after the plt.plot, run plt.show, open and close parentheses. You'll notice that when I ran plt.show, I no longer see that little output of the line. So keep that in mind. If you're running this as a .py script, you need to add in plt.show. Okay. So what we're going to do here is just show you just a couple of basic tools for just quick basic plots. I'm going to copy and paste a data frame that we have in the lecture notebook. So I'm just going to copy and paste this. This is from the lecture notebook on Matplotlib, which really quickly creates a housing data frame for us. This is typical of maybe what we're going to see throughout the course, something like a feature, like the number of rooms versus the price. So what I want to do here is do some sort of scatter plot of the rooms versus the price. So one way I can do that is by simply saying plt, and for a simple scatter plot, I can call plt.scatter, pass in rooms, and you'll notice with plt.scatter, if I do shift tab here, it takes in what you want on the x-axis first, and then what you want on the y-axis. So we'll say plt scatter, housing rooms, and then housing price. So we pass in those two series, and then Matplotlib will go ahead and plot this out as a scatter plot for this. Now, if you accidentally just did plt plot, what's going to happen is it's going to automatically think it's a line plot. So just keep that in mind. In this particular case, we wanted that scatter. So we'll go ahead and say plt scatter. So there's a couple of things we can do for style calls here. You'll notice that if I recall plt.plot x comma y and run this, my axis starts a little bit before 0 here at the edge. And also there's no labels or titles. So let's first show you how to add in labels and titles. For a title at the top of your plot, we're going to say plt.title. To label your axes, we can say plt x label for the x-axis label, and then you just pass in whatever string you want. And then for the y label, you say plt.y label and pass in, again, whatever string you want. So then when I rerun this, I can see here title, y label, and x label. And if for some reason you don't want to see this output, you can just add a semicolon at the very end of your last matplotlib command, run that, and it will go ahead and remove from the Jupyter Notebook that little output and just show you the image. Now, another question I get from students is, how do I actually affect the axes limits? Notice here it looks like the line stops a little short. It might be nice if we just cut off the plot from 0 to 2 on the x-axis instead of extending past it a little bit. For that, what I can do is after I call plt.plot, I will add in a command, xlim, and then for this, I set my lower limit, such as 0, and then my upper limit, such as 2. So notice right now, it goes before 0 and after 2, but if I run this renew x limits, rerun that cell, you'll notice now it starts at exactly 0 and then goes to exactly 2. And I can actually do the same for my y-axis. I can say ylim, and really I can set this to whatever I want. So maybe I could set this starting at 0 and then go all the way to 300. And notice now the y limit on the y-axis actually starts at 0. So keep that in mind. I can add titles and labels with these 3 commands, and I can set my limits with these 2 commands. Last, what I can do is add in colors and markers. We won't really mess around with this too much in Matplotlib. Instead, we'll be using Seaborn for something like this. But if you wanted to change the color, you can say color is equal to, and then you can pass in any main color string, such as red and all lowercase. Run that, and it will change the color. The other thing to note here is that you can decide on a marker to mark each of the points. And you can check out the Matplotlib documentation for what markers are options. You can do a lowercase o to see a little dot there, or you can do something like an asterisk, or an asterisk. If we run that, we can see a little star. So there's lots of different marker options. If you want to make them a little larger, you can say marker size is equal to, and then just kind of choose an integer size. So for example, if I wanted to make them really large, I could say marker size 15, and they should be 15 times larger than average or by default. And then we can also affect things like line style. And for example, I can pass in 2 dashes there for a string code, and that gives me back a dashed line. So for these sort of things, as far as what string options are available to us or what parameter calls are available, if you do Shift Tab here, you'll notice it actually doesn't tell you. Instead, what you have to do is you have to kind of go through these examples here, and it'll eventually talk about things like line width, marker size, line style, etc. And you'll notice this is an extremely long documentation string because it has all the options available for you here. So notice it has kind of all the styles, line thickness, etc., all there for you. So you can check that out in the doc string or just go to the documentation. As far as this lecture is concerned, the main thing you should know how to do is just a very simple scatter plot or a very simple line plot. That's essentially all we're really going to be using Matplotlib for. Later on in the course, we may be doing a couple of things like editing X limits and Y limits for other plots, but really this is all we need to know about Matplotlib for the rest of the course. Thanks, and I'll see you at the next lecture where we discuss the basics of the Seaborn plotting library. Welcome back, everyone, to this lecture on Seaborn. Seaborn is a visualization library built using Matplotlib that focuses on creating standard statistical plots with a simple one-line function call, and it works especially well with the Pandas data frame. This comes at the cost of less customization options than pure Matplotlib. So keep in mind, you're not going to be able to customize every Seaborn plot exactly how you see fit through straight Seaborn parameter calls. Sometimes you'll have to reach into Matplotlib to actually work with the plot for further customizations. For now, let's head over to a Jupyter Notebook and show you the very basics of how to create statistical plots with the Seaborn library. Let's jump to a notebook now. Okay, here we are at this Jupyter notebook. To begin working with Seaborn, what we first need is a data set. So I'm going to say my data frame is equal to PD read CSV, and I'm going to, since I'm located in the exact same location as the actual Seaborn Basics notebook, I have to go out one, then reach into data, and this file is called heart.csv. To begin working with Seaborn, we import Seaborn as SNS. So let's discuss just a few of the basic plot types. There's a distribution plot, which is essentially a histogram. And if we call SNS.distPlot, we can call it on a single column, and it will show you the distribution of the data. So if I say DFH, this will show me the actual distribution of the overall age data. It has both a kernel density estimation, which is this line, essentially estimating what a probability function would look like for this data, and then it has a histogram. If you want to turn off this KDE line, what you can do is say KDE is equal to false. Run that, and then here we see our actual, essentially, histogram. A histogram is essentially just a count per bin. So I can see here that I had these what look like columns. Well, each of these is actually a bin, and the y-axis is defined by how many counts fall for the left side and right side of that bin. So for example, here on this kind of really tall bin, the tallest bin there is, it looks like there's about a little over 60 count. And that means that for this range in the bin, so it looks like ages, maybe something like 58 up to 60, there happens to be around 60 people there. Now, for what, I can affect the bins by saying number of bins is equal to, maybe I only want 2 bins. In which case, if I run that, now I just have 2 bins, which essentially goes from a little less than 30 to kind of midway around maybe 54. And then the count there is somewhere between 100 and 125 points. So obviously, depending on the size of your data set, you can affect this number of bins, which in turn affects the actual width of the bins. Now keep in mind, if you start asking for too many bins, for example, let's make this something like bins is equal to 50, you'll end up with lots of empty spots because there happens to be no data points for that particular bin. Okay. Now, if you do want to change the size of this plot, what you can do is make a call right before this Seaborn using Matplotlib by saying plt.figure, which essentially calls the underlying figure that Seaborn is working with, and then say fig size is equal to, and then you pass in a tuple of how large you want the figure. So I can say something like 12 by 8, and this will resize this to 12 by 8 inches. And we can kind of stretch it out if we want to. So for example, if I made this 3 by 15, you can see how that is stretched out. So this 3 representing kind of along the x-axis, this 15 representing the y. Okay, so other things we can do here, let me turn this back into a more normal looking plot. Let's just say 8 by 8. Other things I can do here, in fact, we can make it a little smaller. 8 by 4. So other things I can do here are set the color. So I can set color strings, just as we mentioned before. So I can say something like the color is red, and I can also play around with the bin size. If you do Shift Tab here and expand on this, it will show you the various other things you can do, such as different fittings for the KDE, different labels, etc. But keep in mind, most of this is designed to be just very simple calls. In fact, you'll notice that the X label, or the label for the X-axis, was automatically determined from the name of the data frames column. So now let's go ahead and show you a count plot, since we'll be doing that as well. If I take a look at the head of my data frame again, here, maybe I'm interested in the count of the label, essentially the target, whether or not they have presence of heart disease, per sex, male or female. So I can say SNS.countPlot, state that I want the X to be equal to the sex feature, and then say my data is equal to this data frame, DF. Run that, and essentially what this does, this is essentially a group by whatever you have on the X-axis for a count call. So this shows you the counts for, in this case, X is equal to sex. So how many males you have in the data set versus how many females. Then we can do this same thing for the target, which is really important actually. Later on in machine learning, we'll see that it's usually a good if you have balanced classes. So here I have roughly the same amount of 0 targets as I have 1 targets. Then we can do other things like CP, which if you go back to the actual notebook, you can look this up and see that it's like chest pain type. So there's actually various types of chest pains, and we can see the count for that as well. Now, maybe you're interested in the types of chest pains, not just the count, but count per sex. So what's really cool about Seaborn is you can add this hue call and add another categorical feature, such as sex, and it will then divvy this up, not just by the pain type in their chest, but by the hue. So it'll show you for both male and female per CP. Okay. Now, the last thing I want to show you is that you can actually affect the palette here. So if you don't like these colors, you can say palette is equal to, and then you can pass in a string code that corresponds to the color mappings that are available in Matplotlib. And if you take a look again at our notebook and scroll down, we discuss this right here, where we essentially provide you a link to all the color mappings. So you can add colors based on the color maps. Sometimes certain color maps don't make sense for every data set. You want to be careful. For example, here, it looks like we're dealing with categorical data, so it might make sense to deal with category-based color mappings. So if you come over here to choosing color maps in Matplotlib, as you mentioned, Seaborn is built directly off of Matplotlib. Simply scroll down here. Here it sees all the code, but this is actually the colors that we can use. So there's sequential color maps. There's two types of sequential color maps. There's diverging color maps that go from one color and diverge into what is kind of like an opposite color. There's cyclic color mappings. There's qualitative color maps. These would probably be good choices for things like categories. And then there's just miscellaneous color mappings. So here are all the string codes that correspond to those as well. And you're free to choose whatever you want. So we'll come back to Seaborn Basics and recall, for a lot of these Seaborn commands, you affect that by choosing palette. All right, the next plot type I want to share with you is known as a box plot. And I'm going to quickly explain what the box plot is. In our Seaborn Basics notebook, we have this little image here of a single box plot. So if you already know what the box plot is, go ahead and kind of fast forward for this part. But I'm just going to quickly explain the basics of what this is trying to display visually. What the box plot attempts to do is show you the distribution, and specifically the distribution across different categorical features. So here we see just a single box plot, which shows just a single distribution. And what this does is it splits up the data into 4 equal parts. So here we have these different percentiles, and we have right here in the middle this what's known as the interquartile range, the data points between Q1 and Q3, where Q1 is a 25th percentile and Q3 is a 75th percentile. So essentially what that means is the middle 50% of all points. So if you had 100 data points, then the middle 50 points are in between somewhere in this box. This line in the middle of the box then splits up all the points in half. So 50% of the points on one side of the median, and then the other 50% of the points on the other side of the median. Then we have these minimum and maximum values, which are calculated with the interquartile range. So these are often known as box and whisker plots because we have these whiskers extending off of that middle 50%. And this minimum is established as Q1 minus 1.5 times this interquartile range. And then we decide that anything outside that particular minimum or maximum based off that interquartile range are going to be outliers. So then we just label those as points. Okay, so now let's build our own box plots and see why they can be useful, and head back to our notebook that we've been working with. What I'm going to do is call SNS.boxplot. And let's set the x-axis to sex. And then I want to see the distribution of age across this category. So again, for box plots, the y should be a continuous feature. The x should be a categorical one. And then we just need to say data is equal to df. And now I can see the distribution of the ages across sex 0 and sex 1. So here we can see that it looks like sex 1 on average tends to be a little younger than sex 0. Now what I can also do is start kind of comparing other things. Maybe I want to compare the actual target against categorical 0s and 1s against a feature. So one of the features could be if we look back at Seaborn Basics and come up here, there's this maximum heart rate achieved feature. So let's go ahead and kind of copy that one in. We'll come back here and set that as our y. So then we run this, And now we can compare the maximum heart rates achieved for people with the presence of heart disease versus not having it. And it looks like there's kind of something different here between them, especially between the averages of them. Okay, then maybe I want to add a hue here to see how this is affected by sex. And what I can do is say hue is equal to sex. And now I can see not just the heart rate per target category, but the heart rate per target category per sex. So now I have these 4 box distributions that I can play around with. And if you want to see more examples of this, you can definitely check out the Seaborn documentation. I want to show you 2 more things, which are scatter plots and then a pair plot, which is essentially a scatter plot for your entire data frame. So let's show you what a scatter plot looks like. You should already pretty much be familiar with scatter plots if you have some interest in machine learning. But essentially what this does is you pass in some feature along the x-axis and some feature along the y-axis. So I'm just doing some sort of beats per minute feature and then state our data, run that, and here we can see a scatter plot. So essentially for each data point, we just grab these 2 values and put a point on the map. So what I can also do is start adding in hues to color points differently based off a category. Again, maybe I can choose sex for this. And then what I can also do is start playing around with the palette. So maybe I want these to be colored differently. I can say palette is equal to dark 2, for instance, and then I can see these results. So if you're colorblind, you may want to play around with the palette until you can distinguish the points correctly. And you should also be keeping people that are colorblind in mind when you're performing visualizations that are dependent on color. And finally, what we can do is we can also change the size of these points based off a feature. So for example, I can say size is equal to age. And you'll notice that the larger the point is, the older that particular person is. So as we begin to play around with these visualizations, we can actually display a lot of feature dimensions on a 2D plot. So here we're actually showing not just this beats per minute versus this cholesterol feature, but we're showing also the sex and the age. So lots of information here on what is actually just a simple scatter plot. So very useful. And then last thing I want to show you is something called a pair plot. Often when you're dealing with a smaller data set, such as the iris data set. So let me load that in. We'll say iris is equal to PD read CSV. And then we'll say data iris.csv. So the iris data set is probably something you are familiar with. Essentially shows you 4 features of flower petals and sepal lengths and widths, and then the species of flower it actually is. What you can do here is you can call sns.pairplot, and then you just pass in either an entire data frame or a subset of data frame columns. Run that, and what Seaborn will automatically do for you is the following pair plot. And what this does is it creates a histogram of each of these features along the diagonal here, and then performs a scatter plot for each comparison. And you should note that for some of these, essentially along the diagonal, you should get duplicates. So for instance, here we can see petal width versus petal length, and it looks like there's a strong relationship there. And if you keep going across the diagonal, you'll notice it's actually the exact same plot, petal width versus petal lengths. So it should essentially be mirrored across this diagonal. Now there's lots of different options here you can play around with. You can start adding hues. So for example, you can say, give me the hue per species of flower. Run that. And then you'll see the it'll change the histograms to be KDEs, essentially kernel density estimation plots or distributions of these actual features per species. So this is a really nice way to quickly get an understanding of all your data. But you should keep in mind that the larger your data frame, especially on number of rows and number of columns, the larger this pair plot's going to be, and it's going to be harder to interpret, and it's going to take Seaborn longer to actually develop it. So don't just run pair plot on huge data frames. Otherwise, your Jupyter Notebook will be stuck all day waiting to render this giant plot that may not be useful to you. Instead, maybe try to select subsections of the plot based on some sort of analysis of the data frame beforehand. And keep in mind, you can always just perform your own histograms or own distribution plots or your own scatter plots for any combination of features you're interested in. Okay, thanks. And coming up next, we're going to set you loose on some exercise to test your new Seaborn and Matplotlib skills. I'll see you there.